Alright, so tonight we brought a whole slew of Mikrotiks and Mikrotik parts and stuff. I think everybody here has been to one of our Mikrotik lectures before, so this shouldn't be completely new. On Facebook we kind of said we'd talk about firewall and QoS, but I think we're just going to jump into it and see where we go, if that works for you guys. Alright, this is Winbox. This is the utility that talks to Mikrotiks. There's lots of other ways in. There's a web interface, you can SSH in, you can telnet. There's an API if you want to script it or have a program interface. Alright, so there's two routers here. This is the one I'm plugged into right now. And then this one is the one Nathan just gave me, which is Blink. As you remember, hopefully, from the first time we talked, you notice how the one that's Blink doesn't have an IP set. It's all zeros. And then the MAC address is listed. We're going to connect to it through the MAC address for the first time since there is no IP. So this is a layer 2 communication. Anybody that's familiar with Cisco might have heard of like CDP, Cisco Discovery Protocol. Most networking equipment has some sort of low-level discovery, and that's what we're going to use. So by MAC address, we're going to connect, no password, and here we are. So for some of the first things we want to set up, let's give it an IP. So let's go to IP DHCP client. And we're going to add one. Ether1 is what I have plugged in, and it's plugged into the lab network here. So we're just going to hit apply. And you see it already grabbed an IP from the lab network. So at this point, we should have internet on our router. Ping doesn't work, so we can't really test it that way. See? It went out to the internet and it found an update already, so we know internet's working. We're going to go ahead and do the update. I did that by going to IP packages, system packages I mean, and then check for updates, and it brings up this nice update screen. Give it a second to come back to us. Now we can connect to it by IP. So now we're in. Let's give it a name, especially since we're going to have several routers. Let's call it WuLUG R1. Now where do you want to go with this? We're going routing or we're going firewalling? How many routers did you bring?
Lots.
Should we set up OSPF?
Let's do.
We've hinted on OSPF and never done it.
Yeah, let's get an actual network setup first. So let's do like, DHCP server with NAT so that everything works kind of like it's supposed to.
Alright. So far we're mirroring what we've done before. We're going to set up a bridge. Let's call it private. And we're going to add all the ports from the router besides Ether1. Ether1 is our connection to the lab network, right? So we don't want it to be in our bridge. The bridge is going to bond all of the private ports that are going to be our own little network. So we're going to make that Ethers 2, 3, 4, and 5. I'm going to leave WLAN 1 out of it for now. But once we go back and configure WLAN 1, we'll decide what we're going to do with it. So we're just going to put everything in the bridge. Does anybody remember the other way to do this besides adding them all to the bridge? Which is actually faster. It's a better way.
More efficient for your.
Didn't you do bridge public and a bridge private?
Yeah, but we probably won't do that today. That's if you want to separate, if you want to have like an open public network and you want it to be separate from your stuff. So this little thing over here, which I kind of forgot about when I added them all to the bridge, you could actually get an interface to the actual switch chip that's built into the router. So underneath the routing, if I want, let's take these back out. Let's only leave Ether 2 in the bridge. And if we go to our interface list, we see there's an S besides Ether 2. That stands for slave. That's because it's in the bridge. When I had the others in there, they also had an S. I'm going to accomplish the same thing, but this time I'm going to add it to the switch chip. Because I can click on the interface, and then under master port, I can tell it what port to bond itself to. So I'm going to put all of them underneath port number 2 on the switch chip. And this is much faster than bridging. But
by faster, you don't mean faster in terms of configuration, you mean faster in terms of data throughput.
Yeah.
yes,
The CPU.
yes, much more efficient. Because now it's actually using the switch chip for the processing, not the CPU. Whereas the bridge is all going to be inside the router CPU. So we're offloading thought power.
So each port on there becomes a port as a switch.
Yep.
Port.
And you can add or remove whatever ones you need. So if you want to have one separated for routing purposes, because you can't firewall and stuff if they're in a switch group. You can't firewall between the ports on what they're coming in and out of. So you've got to isolate things if you want to separate things from certain things.
So there he said something very interesting. If this is faster doing it this way, then when would we not do it this way? When we would not do it this way is if we wanted to actually firewall everything within the bridge. When we do firewalls, a lot of times you don't really care as much about your bridge. Go ahead.
Well, isn't Ethernet 2 firewalled, so everything that's passed through?
Well, nothing's firewalled right now. When we get to firewalls, if we firewall, we can firewall by interface, but if it's the switch chip, it's all going to happen before the firewall.
Okay.
So you got to firewall.
But if it's the bridge, then it's going to happen as part of the firewall. Is that cleared up kind of? Okay. Feel free to pipe in whenever you want.
Oh, no. An observation mode here.
So you see under bridge and ports, Ether 2 is the only one listed. However, these all have an S that show that they're slaves. That's because we've added them to the switch chip and then added the switch route to the bridge. Let's set up an IP pool.
Why wouldn't you call them port 1, 2, 3, 4 instead of Ether 1, 2, 3, 4?
This
I
is just
can.
the default. You can rename them however you want, but this is the default naming scheme.
Alright.
Yeah.
Yeah, we can name it whatever we want. I think the reason they chose that as a default is because on their different routers, they have more than just Ethernet ports. Sometimes they have SFP, which can be fiber ports. So Ether just kind of distinguishes that this is an actual Ethernet jack.
Show them the wizard for this.
The wizard?
It's actually a little bit easier.
I hate the wizard.
Told you.
You just never like to make things easy for yourself. You don't like FreeNAS, you don't like Wizard.
I don't like it when people try to make decisions for me. All right.
The wizard actually does all of this, just this.
The wizard does all this, and then you miss the understanding of what it's doing.
There's, yeah.
So we're actually defining our pools here. And then we're going to go to the DHCP server. We're going to make a private server. We're going to run it on our private bridge. We're going to tell it to use the pool we just created of IP addresses.
You got sweet 10-minute lease time too.
Which means every 5 minutes it's going to be requesting this lease.
That's all right. I'm going to give it .3. All right. So this is about as basic as a DHCP lease is going to get. There's a few things.
If you were running a Windows environment and you had a domain, you would want to put in your Win server and your domain controller as well, your domain server in there.
Yes.
So your Win server will be the IP to your domain controller, and then your domain will be the actual domain you're actually using, and it will bring all that in nicely. It should. And Capsman, if you were running Capsman, you could put that in there.
I just saw that. That's good.
We should do a Capsman session sometime. Does anybody know what Capsman is? This thing here called Caps Manager. So a lot of the companies that make wireless networking hardware have these setups now that they've kind of streamlined setting up large-scale access points. And I've used Cisco's. I don't see any of the routers in here. In the hallway, you'll see them. So all of those usually go back to some kind of root, and it's controlled from a root where they can control users and authentication and everything from one master place instead of having to configure it on every individual access point. So Capsman is Mikrotik's version of that. You can connect different routers that have wireless capabilities to a master Caps Manager, and it will essentially take over control of the configuration of the wireless cards and how they're set up, which could greatly simplify setting up wireless access points. So back to our setup, we need to add an IP address. Since our bridge is going to be the gateway to this network, then we need to give it the gateway IP address. And also, since it's going to handle DNS requests, we have to go flip on this allow remote requests. So what is this going to do? Any of our DNS gurus have an answer?
Set up a DNS proxy.
It's going to set up a DNS proxy. So the router itself has a dynamic server. That's where it gets DNS from, which is whatever it got from the lab network. Anything that is going to talk to our router in our DHCP setup, we told it that our router will be DNS for its network. But there's a separation between what it's handing out and what it's talking to. If we click allow remote requests, we're allowing it to proxy from its DNS server to what's below it. Essentially, if we turn this off, DNS server won't be running on a router. Only the client. So what do we need to think about if we flip this on?
Cache poisoning.
We have to worry about security, for sure. If we just have an open DNS server, we always got to think about who's going to try to spam it and take advantage of us. There's a lot of denial of service type stuff that's going on in the DNS world. In my experience on the internet, if you throw out a Mikrotik that's not firewalled for DNS, it's just an open DNS server and you throw it on the internet, I mean, under 2 hours usually, you're getting spammed pretty hard by all over the world. And that's not just Mikrotiks, it's anything. It just depends, kind of. So we need to remember that. I'm not worried about it right now because I know we're behind the university's firewall, or the computer science department's firewall, should I say.
Now, just before you move on from DNS settings,
Yep.
your brother gave a wonderful lecture on FreeNAS, and you continued it, and talked about using the FreeNAS box as a DNS server. It needed to be a DNS server.
Right,
If
when
you were
we're,
running-
yeah.
If you're running that alongside inside the Mikrotik system, would you still use the Mikrotik as the primary DNS, or would you turn that off?
It depends.
No,
There's a couple ways you could approach that.
Yeah, you can statically set it, but in DNS, in your DHCP settings, it's best to just set up your domain control as.
In your DHCP settings, you will have to make sure that your Windows clients, because what we were doing was Active Directory. That's why we made FreeNAS a DNS server. So all of the clients in their DHCP lease need to point to the Active Directory server. But the Active Directory server will then need DNS from somewhere. So you could just not worry about it in your router and have it pointing to whatever a good, healthy DNS server is that you have access to. Or you can still use your router as the middleman, and essentially your Active Directory domains will be the only things that are proxying through it, because everything else talks to them directly.
And it will cache all your public addressing.
That's the beauty of it.
Resolution.
The beauty of it is that it's acting as a cache. So you'll have a local cache, nothing's going through it yet, but you'll have a local cache of DNS. And that's where it's useful.
And you can find your own static routes as well, your static DNS entries. So if you wanted to statically assign just names of servers around your network, just install your static area there.
Oh, so
Yeah,
you,
and
so
static.
you can do that on
Yeah, and
Okay.
it'll start resolving.
Okay, so it's
See right there.
so it's almost a full bind.
Kind of, yeah.
It's like a super light bind.
It's really light.
Super light, yeah.
It doesn't like
You're not-
none of the advanced features
You're
you're
gonna
gonna
reverse
have.
DNS at all.
Yeah, and you're not going to be able to handle like hosting MX records and things like that, or pointer record. Well, pointer records are all you can host. So
Can
A
you,
records, sorry.
Can you do CNAMEs or just direct?
Just a.
I'll
Just-
try, to be honest.
I don't know if there's another DNS package you can install.
No, I mean, in the address blank.
Oh.
I don't know if you can just type another host name in.
And basically just do a CNAME.
Hmm.
You try it.
It'll probably resolve. Let me get something that won't resolve.
In a different IP, possibly.
It's mad about that
I
already.
don't think it blanks it, but you try it.
It's not
It may have to
Yeah,
resolve it.
it wants to resolve it to an IP. So the answer is no.
Okay.
Yeah, it's gonna convert it.
Okay, is that good for DNS for now?
Yeah, it's pretty strict. Yeah, Arctic's not real full-fledged on DNS. They do it a little bit. They do enough.
Now, just because I've just started to play with DNS stuff, could you still use it as a proxy and have your main DNS server and it becomes a failover
Yep.
if that server
Mhm.
goes down?
Yep.
As long as you weren't looking to host a bunch of records on it.
Yeah, because it won't carry your records over.
It only caches. It's basically like unbound by default.
Right.
Okay.
Okay. Another one that I set a lot of times is I'll set NTP because I like to set my routers up, especially my border routers, as NTP servers. Why is NTP important? Why is precise time important? There's two reasons, really, two main reasons. Number one, so logging is accurate amongst devices. If anything ever happens and you're going through logs, especially if you're trying to troubleshoot a specific event, even seconds being off might matter in trying to figure out the order of the event that happened when you're looking across multiple devices. The other reason is a lot of security features require precise time. There's a lot of instances where if you're running like IPsec tunnels or OpenVPN type stuff, that the keys will mismatch because the time's off and they'll just drop the tunnel. So for security and for logging are the main reasons that I make sure everything has precise time. Okay, we got a network set up, Nathan. Where do you want to go now?
We can do either. We can do the NAT rules.
Oh yeah, NAT. Sorry, forgot about NAT. So right now my network can't talk to the outside world.
Oh, I can.
Yeah, there's just no way back. It's not routable to the outside world. How's that? So NAT, network address translation. This is where, and we've talked about this in here before, if you have a device that has a public IP, and then you have a whole network of IPs behind it, like in our router, we've grabbed an IP from the lab, we're going to treat that as our public, and then we've made our private network underneath it. So if we want our private network to talk out of our lab IP to the outside world, then how is anything that returns going to know what to talk to when it can only talk to one lab IP? That's where NAT comes in handy. NAT is gonna masquerade all of our private network behind this one IP, and it's going to keep a table of how to reconstruct that information. It's going to track every device that talks out, every connection, and it's going to say when it comes back, change my public IP back to this private IP behind my private network and deliver the packet. That's what NAT does. So right now, without a NAT rule, it would appear that our internet's broken. So we're going to add a very simple NAT rule.
Do you know why though?
Why?
I mean, because technically, if you were using public IPs, you'd be routable right now and you wouldn't need NAT at all.
Yeah, I was gonna ask that.
So it's not necessarily because it's not routable because of the router, it's not routable because it's using reserved IP addresses that are blocked past your border router, upstream router.
Because no other router is going to have a route to the outside world.
Route back to a private
Yeah.
address that's blocked, but if you were using public IPs, this wouldn't be a problem.
Right.
That's just a valid point.
It's a very valid point.
Yeah. Anything in the 10 dots, 192 dots, or 172.
172.
Pretty much won't come back.
Like 172.16.
Go out, but then they trapped.
Most ISPs will block private IPs as soon as your connection starts.
And it's a good practice.
But some ISPs don't block them at all. So you could potentially have private traffic from your private network going all the way to some random web server somewhere in the world. It won't be able to get back. But that's not good. That's not something you ever want to let happen. That's a massive epic fail of firewalling and networking if that is allowed to happen.
Or at the least an oversight.
At least an oversight.
That's quite the oversight. All right, so we're going to say anything that comes from our private network that we've set up, this 192.168.3.0/24, everything from that network as its source that comes from that network going out Ether1, because Ether1 is our public. We want to masquerade. So now we have our rule. I should connect through the router or something. So this is our masquerade rule that's going to make all that happen. We're routing or we're going to go firewalling?
What is what do people want to talk about? What are the people more interested in around here?
Firewall.
Do you guys want to connect a bunch of several of these Mikrotiks and do routing in between them, and then play with different ways of sending data between them, or do you want to or do you want to focus more on just one and the tools within it? I mean, we'll kind of touch on everything either way.
Yeah.
Can you explain masquerade? That means hide it?
So masquerade is where we take our private network and hide it behind our public IP. So it is hide it. We're hiding our private network behind a single public IP as it talks out to the world. And our router is what's going to do the logic that says, from this private address to this somewhere on the internet, I'm going to put it behind my public IP, and when it comes back, I'm going to take my public IP destination off and switch it back to the private IP behind me that made the connection.
Although it's hid, can it be pinged
Only if you allow it.
if you're inside?
If you're inside, yes. If you're on the outside,
No.
hmm?
You can't? On
No.
the inside?
No. If you did some magic to push ping through, you could, I guess.
One host.
Yeah, to one host. Even if you did magic to make it work, it would only work to one host, to one individual IP. You would have to change it every time to a different IP if you wanted to. So by default, no, and usually not ever. Only if you really went out of your way to try to make that happen.
Also, in IPv6 originally there was no NAT, there was no masquerade.
Is there now? See, I know very little
Because of pressure, but there's a lot of resistance to it.
because there's no need.
Yeah, there's no masquerading. You're supposed to do public networks throughout your whole infrastructure,
Sounds good to me.
and then properly firewall that network.
To me, masquerading oftentimes takes focus off the firewall, which isn't good.
Because a lot of people feel it is a firewall
But it's
by
not.
its nature, but it's not. It's just a.
Masquerade it, do you need a firewall?
Absolutely. Because there's nothing actually stopping the traffic.
It's a level of firewall protection, but I would consider it like the bare minimum. It's not safe. It's just.
That was never designed to be a
Even though it's
firewall.
masqueraded, the
Designed
data
to-
will flow, so.
That's right. The data's going to flow, even though it's masqueraded.
It's designed to save IPs.
Yeah.
Yep.
That was never
So-
designed to protect.
You can talk all night about that.
I know, but there's really nothing else to talk about.
There's lots more to talk about.
There is, but our original NAT conversation was a good one. You would have liked it. We actually drew packet diagrams and did network flows and stuff. Do you got another router ready? Let's connect a couple routers.
It's reset at this point.
Oh, you got wireless on it, huh?
Yeah.
Should we connect them through wireless?
I gotta finish eating things over here.
How many wireless cards does that have in it?
It's got two.
Two? All right, let's go to the wireless in this one. You notice it's grayed out. That's because it's disabled right now, which I want it to be. Let's put it in AP bridge mode. Let's look at these modes on the wireless for a second. AP bridge is where it's going to act as an access point and then bridge that access point to, let's say, maybe our private network that we set up, our private bridge. That's normally what you're going to use it for, unless it's just a client that's connecting to an access point. Bridge mode would be just a point-to-point kind of bridge. I don't really use it a lot. But it's not going to, it would be your point-to-point, right? I don't really use bridge mode. It's just point-to-point, right?
It's just for point to point. It
Right.
will only allow one client device.
So it's quite literally just a wireless bridge from one side to the other. In-stream dual slave. The in-stream is a proprietary Mikrotik protocol. Is it point-to-point as well?
Yeah, pretty much. Yeah.
It's meant for point-to-point.
It only works real well on 5 gigahertz, not 240.
So it's meant for long backhauls with Mikrotik hardware. It's their proprietary protocol that they've fine-tuned with their hardware to try to make it as efficient as
Does
possible.
an in-stream dual require 2 radios?
Yes.
Yeah.
Yeah.
You have to have a master and slave.
It's kind of a weird thing. We tried it once more, really impressed.
No, I have lots of, it eats up your CPU like crazy.
Isn't it the analogy to Ubiquiti Air Fiber?
It's their version of Nemo.
No, I think Ubiquiti Air Fiber is GDMA, which is more like NV2.
Yeah.
Is that? Oh, okay.
Yeah.
All right.
Yeah, they just have precise time.
Station is just like it says. It's a station where you're going to connect to an AP. It's the client. It's just a wireless card that's going to connect to some access point. Station bridge, station Sweater bridge, and station Sweater bridge clone. We'll kind of cover those all three in one. I don't know the finer differences between all of them, but essentially what you're doing when you bridge the station is you're taking your client and then you're bridging it to whatever's beyond it. The reason that this gets convoluted is because that wasn't really meant as part of the original wireless standards. So a lot of this has kind of been hacked. I don't know why station bridge isn't usually what you want. Usually if what you're trying to do is connect as a client to an access point and then bridge it to an Ethernet port on the other side that you're going to connect to your computer, Sweater bridge is what you want.
Yeah, for routing, if you're just doing pure routing, just do station. If you're actually going to bridge them,
Right.
then you would use station.
The station bridge, I think, is generally for point-to-point links.
Okay, so station Sweater bridge is usually what you're going to use to connect your computer behind this device that's connecting to your local network. Station bridge, like he said, is meant for just a point-to-point station kind of thing. I don't know what station Sweater bridge clone is.
Regular station is just regular, as many clients.
Right.
Every client can be a station.
Right.
If
The clone, I don't know.
if I
Clones
was
the MAC address of whatever's plugged into the Ethernet interface.
Ah, that's very valuable. So Jaron just let us know that the Sweater bridge clone means that it's going to clone the MAC address of whatever device you plug into the Ethernet side. Where bridging a wireless point gets ugly is ARP. And that's where Sweater bridge is kind of your friend, depending on what you're doing.
if I wanted to set up a home network with say 3 of these, and they're all hardwired connections, but I want to turn them in each one into a wireless access point, but for them all to be coordinated so it just creates one big wireless.
The easiest way is Capsman.
Connection.
Capsman, yep.
Okay.
Capsman would be perfect.
You set 'em
You'd
all-
have your 3 access points and then a core router, which one of your access points could be the core. And then you just use Capsman to manage all the wireless.
So you don't need to do any of the bridging or.
All this goes away.
Not at the wireless interface level.
Yeah.
Okay.
It brings all the wireless interfaces back to your Capsman server, or whichever router you set it up on. And then from the server, if you just change like the SSID on the server, all the clients will basically be changed.
It's
If you set up a security key on it, it'll just broadcast that security key.
And to an ordinary client like a laptop, it doesn't matter which of the 3 APs they're
No.
connected to, they'll just jump from whichever one
Yeah.
is
The default-
hottest to the next one.
Yeah, the default with Capsman.
Well, yes and no, actually.
Yeah, they won't hand off. That handoff doesn't actually happen unless the client actually has some kind of protocol built in for the handoff mechanism.
There's nothing built into the normal wireless protocols that deal with handoffs.
Yeah.
So usually what happens is when you get far enough away that your signal degrades enough that you disconnect, then it'll look for the next one, which is usually way too late to hand off,
Right,
to switch seamlessly.
The Capsman default signal strength for that drop-off is 120 decibels, maybe 120, and that's really bad. It would probably never even reach that before you started realizing things were going wrong. So it's best to find that. You can see the Capsman like maximum client, signal strength, and set it down to like 80 dB or something, and that'll And then they'll reconnect to the next one that's higher powered.
Okay.
The reason that there's a Suedo bridge on station mode is the 802.11 spec does not allow station mode to be bridged. AP, however, can be. So when an 802.11 device is in AP mode, per spec it can be bridged, but not when it's in station mode. The Suedo bridge is a hack. So back to your original question, if you were to set up several APs and had tunnels going back to a core or something, you could bridge those tunnels with the APs and it would work fine. You don't have to use Suedo bridge or anything like that.
Right, this is only for like the client, the station.
Yeah, AP bridge is your standard wireless hotspot. Wi-Fi.
Okay.
And then station WDS and WDS. Oh, sorry.
Let me ask you a question about the Mikrotik.
Yep.
When you boot that up and you start to configure, is there defaults that they choose
Honestly,
to say this is norm?
If you want to go into, I don't mean to be rude, if you want to do a dummy setup real fast though, there's that button in the upper corner that says quick set, and it'll automatically set up the entire router for you based on presets.
Where's that button?
Right here, quick
It's
set.
really not good practice though. It misses a bunch of stuff.
You don't really understand what you're setting.
You should probably know about. Yeah.
But for, you know, when you know what you're doing and you just want to get it set up real quick, it works great. So it'll set you up in 10 minutes or less.
Yeah, because these routers were never designed to be like your Linksys. Give it to somebody, plug it in, and everything would be there. You know, it's made for more of a, I know what I'm going to do with this. We're going to lock it down. We're going to make it specific to what I need. And it'll work perfect like that. So.
There's also, they come a lot of times with a config on them that is set up for like a home router setup. So that way it just works out of the box if that's what your goal is. It's for your home router. But I always wipe it first thing usually and start fresh. So, and what it comes with by default is essentially what you're going to get when you do the quick set. So.
Well, you can find two quick set them.
Yeah.
There could be something said for a newbie to bring up.
Honestly, it's a great way if you're just wanting to get into it and then start poking at it later and learn. It's a great way to get it set up right off the bat.
And if you guys ever do pick up one of these Mikrotiks, which they are cheap for routers, they're on par with, if you just wanted to go buy a Linksys router, they're going to be about the same price anymore. And
Cheaper.
Yeah, sometimes even cheaper. They have way more functionality.
Yeah, they got one of those 20 bucks now.
Yeah, so if you guys ever pick one of these up and need help, I'm always.
It works
I'm always
awesome.
in the
I put it in
IT
Jess's
channel,
shop.
so
She loves
You
it.
can always shoot questions.
Wow, it works way better than I thought it would.
Not locally, but you can get them on Amazon and they'll get to your house in 2 days. So
Yep.
sometimes it's faster than local.
Yeah, if there's a company in Pittsburgh, Kansas that sells them, if you really feel like you have to drive out there and pick it up right now.
Where's that?
There is a company in Pittsburgh, Kansas that sells them.
We sell them.
What's router?
Oh yeah, they Wellington. They usually have some in stock in Wellington. That's actually usually what I do.
Who has them?
Sumner Communications.
We actually sell this
You
one.
reseller.
We sell
Yeah, we resell
this
them.
one right here,
We are
which has
reseller,
wireless
too.
in it, and then it has 4 gigabit or 5 gigabit Ethernet ports in it as well.
So probably in the spring, I'm looking at redoing my home system.
How much is it?
Would you
This
like
one is
me to come to
$100.
you? or
We
shall
sell
I
a
just
smaller
take
home
it?
Yeah,
with
you don't wanna order it
gigabit
yourself.
for $60.
I mean, we have to put our month upon it.
And we just got a new one
That's what I
in.
mean. Do you
It's
want
going to
that
be like
money?
$40.
We'll take your money.
Right now.
We
And
love
it's
money.
The one that's like
But there's something
$40.
said for
It's
buying
an
from us
actual
too,
home
because when you have a
router.
problem, you should call us and usually.
But it has all the functionality. You don't lose any
What I'm
micro.
saying is when I look at your menuing system up there, you're talking that's $100,
Yeah.
and I'm putting in sonic walls for 1,000,
Yep.
Yeah.
1,500
These kick
plus.
this.
What we're saying.
Yeah.
Kick the heck out of
And
the sonic
the
wall.
nice thing about the
That's what we're
Mikrotik
saying.
routers is they sell everything from this little home jobby up to 24 port gigabit or 12 port fiber optic
I mean,
switches.
this thing, I see it available.
Yeah, we
And
have,
it's-
we bought it 10 years
As
ago.
much, if not more.
Yeah, and it's all the same interface
$3,500.
between all the routers. It's the exact same
Was
interface.
it- was it
the
all
exact same
SFP
functions.
gauges, or was
you can
it-
do anything between all of them. So
Like
they're marketed in the
eight?
same language.
That's awesome.
Yeah, it's a
So I got one more question.
Yeah.
On my sonic walls, I can go in and I can block the complete country just with a check mark.
Yeah.
Is there something like that?
Not as easy, there's no checkbox for it, but there are lists you can get, and you can block by listing.
But you gotta put them in menu.
More or
Yeah,
less.
you'll probably touch on it with the firewalls, right? The address
Yeah.
list.
Yeah, the address
That would
list.
take a script, but the scripts are available online.
Yeah.
Yeah, I've seen the scripts in the forums that do that.
So instead of a
I've never done it myself, but
Generates it for you.
Well, these
Yeah.
is only with the no sonic walls you can do that. The rest of you had to manually.
well,
The problem
I
is some
remember
of those
reading
lists
this in the
though,
list on
they're
the
not accurate
forums
anymore.
like 5 years ago.
IPv4's changed so much.
Yeah, I kinda like that.
What's it using underneath? Is it using IP tables still?
Yeah.
Like a standard Linux?
Yeah.
I believe it's IP
IP
tables.
chains, IP tables, IP chains, whatever.
Because there's two modalities in the Linux world for firewall, right? I think IP tables is the one it
Yeah, I
uses.
think. And our main CS firewall has been fully scripted by Tom in Perl using IP tables. He just directly talks to IP tables and sets it up himself with his own
How
mouse.
it used to do.
So this will probably look pretty familiar to him.
It's the
as
same.
Yeah,
the interface.
I know that Tom would just run with this.
Yeah, let's do some firewall stuff then.
All right, let's do
we've
some
got-
firewall.
Enjoy it.
So the first things that we need to talk about, I guess, for firewalling is how to torch an interface to kind of just see what we're dealing with in the first place. Yeah, make a bridge real quick. Make a LAN. You're able to local LAN?
You want to put this on as an AP?
Yeah, well, let's just let people connect to it. Do people have cell phones they have with them that they can wirelessly connect? We need to generate some traffic. So people have cell phones or laptops that they just want to jump on our wireless here. Just
Are
make
you bringing this wireless live?
Yeah. That way we can kind of show you how traffic's going to flow through here and what we're going to look at to kind of limit some things maybe. It's not up just yet. We got to set this all up.
Yeah, we're almost there.
HT, turn both chains on. Okay, just apply this. This is fine. I mean, it's not.
I don't want to do this campus.
Yeah.
There's tons of noise on this campus, and I don't want to throw off somebody.
Go 22.
22, you say?
Yeah, go 22.
Oop, it's running from me.
Just 22, man.
All right.
Up, stop.
I'm not coordinated enough to look at a big screen
Yeah, sorry.
and do this.
You gotta bridge it.
All right.
Okay, so you should be able to connect to the wireless.
Should
Watch
be
your
up and
DHCP
running.
server, and you'll see people pop in. That'll be kind of cool.
Okay,
And
that's
your registration, your wireless registration as well. Go to wireless on left.
Sorry, I'm not you. I closed my windows.
Whatever. In the new Winbox, you can select your default
I'm
profile.
annoyed by that already.
Right.
You can select your default profile to none, so every time you open
Okay,
it up, you get a fresh
I'm
new
connected.
screen.
All right, so you see what's going on here? This is our wireless connection. This is who's actually connected to the wireless. And then this is the DHCP server showing what it's handed out.
Oh, your mouse sucks.
So, nobody named their phone anything clever.
I
so
know,
we
I
don't
was
know who's who.
hoping to see something fancy here.
Oh,
I figured
can
I
actually
did.
connect.
I don't know how to name my phone, so.
Yeah.
Here you go.
Usually you have to have a rooted phone just to do it.
Yeah.
I have a radio phone.
The, one more question.
Yeah. Just
There
one?
you go.
Now I'm connected to that.
Correct.
Can you show me up there where I'm connected to anything?
We need to know your MAC address.
You're one of these two.
Yeah, because you don't have a unique identifier on your device. We're
What's
not
the security key?
Shouldn't be one.
There should be
There's one.
free internet.
Yeah, it
Should
should
be
be
open.
Android, so
It's free.
it just says
Free internet.
Just check your Android AP, is that right?
No.
No,
What are you?
WuLUG
Oh.
24R1
That-
or
that
something.
would be
the
one.
Android AP is my
So
feather
there are
hotspot
people
right now.
running some really dodgy stuff.
Probably.
I need to get internet. It's only American internet. I don't have campus wireless. I need to get VPNs out.
So there you go,
That's
JB,
right. You wouldn't be able to with campus wireless.
Keep up with me.
JB249 is this laptop.
There you go.
All right. So there. There's Ben.
He's 96.
And then here's Jaren over there, Voodoo Surface. I'm guessing that's Allie because she said she had a rooted phone but didn't know how to change her name. And then these two, I'm guessing, are you guys. But I don't know which one of you is which. We can find that out once we torch, though. Let's open up torch.
Yeah, so let's see what's on the wireless interface. Let's see what you guys are up to. It's not too much data. You can actually see the rates there. As you people do things, you'll notice that these things jump
On
up.
the top one. That's my MAC address.
We can actually kind of watch some of this
Okay.
under traffic. You get to see kind of a real-time view of what people are doing on here. And we can go and, do they call it?
Torch. Oh, what are you looking for?
There we go. And we can torch, and we can see,
So this is every connection
let's do protocols and ports.
that's flowing through the wireless interface.
So in real time.
This is a really powerful tool, by the
So
way.
you can sort it by rates. You can kind of see who's doing the most. So this person, you can stop at any time if you want to get a freeze. So 97 seems to be taking up all sorts of stuff you can see over on the left source address here. So if we wanted to kind of take care of whoever 97 was if they weren't playing nice, you have to go back and look. 97 is a Voodoo Surface, and if you wanted to, you could kick them off the wireless. You can do all sorts of things. So 97 is.
Let's go back to torch.
575 alpha.
So yeah, so from here, once we figured out the IP, we knew the MAC address, and then we can match the MAC address over here with the actual connection.
Yep.
Fastest wireless I've ever hooked up to.
Well, that's virtue of the university.
Big pipe back there, right?
The reason I select port and protocol will be important in a little bit. I'll talk
Right.
more about
So,
firewalls.
size these up a little bit better. The
What do you want?
left, these two columns.
Oh, I see.
Okay, so every connection here that we're looking at, go ahead and stop to freeze it.
You don't like this view?
So every connection that we're looking at here, it's going to tell us the actual like layer 2 protocol and then the actual protocol. So we know that these are all IP. I guess that's layer 3 really, isn't it?
Yeah, but they're almost always going to be the same. There's
So it's telling us that these are all IP, and then each of these connections, if they're UDP, it'll show up. That's interesting, by the way. Is somebody streaming a video?
Yeah.
Okay. So that must be you. He's got UDP 929. He's got UDP playing through some secure website at this IP address. And wow, that's nice, by the way. That connection rate. Did you see that?
Here, I'll just bring up a terminal real quick. Sorry.
38 megabits per second. That's nice. I'm happy.
Fastest wireless.
That's
right?
good.
We know where he's going.
So we can type in a who is.
94.12.
Yeah. And it's going to query
To a Kansas Research and Education Network.
yeah. So
That alarms.
In Lawrence, Kansas. So you,
What, Jake?
yeah, what were you?
It's just YouTube.
It's just YouTube.
That's what I'm wondering.
That must be something else then.
it's running a lot of data to it.
That's interesting. What is going on there?
Let me turn it off.
Well, we froze it anyway.
Yeah,
so-
no, this is all frozen stuff. But anyways, this is how you can easily kind of track where things are going to if you're curious why something's running so high and where is it going. It gives you the power to look at that a little bit more. You can tell it's on port 443. If you wanted to control port 443 in your firewall, now you know that this is where it's originating from.
So port 443 is secure HTTP.
HTTP, and it's in business use even. So
Yep. Yep. If it knows it, it tells us, which is awesome.
anything else in here?
Most of it's all web.
Web.
Surely Jaren was doing something non-web. What's this?
I was streaming.
35.
From your home?
I'm probably doing some other things in the background, but.
5.4. Yeah.
Yeah, I don't know what that
Nobody
is.
else here.
So pretty much all web.
Let's just kick it
I
on.
could stream from my home.
Oh, there's DNS. Here's DNS coming through.
So yeah, we got some other things. Boot PS, some other things happening.
That is it. Oh. Some IP6.
It does show some IPv6 things.
All right, so let's go to the firewall. now that we've thought about connections and we've got a visual of how things have flown through the router, let's come back to the firewall.
Can you talk about these first?
Does anybody not know what a firewall is? I mean, I assume you all understand the idea. So, and I believe this is an IP tables thing.
The three.
There's 3 chains. And the 3 chains are forward, input, and output. You can make more chains, but these 3 are always there. Input means that this is information that is destined for the router. It's coming to the router, right? So anything that is trying to talk to the physical router is going to be on the input chain. The forward chain is anything passing through the router. So anything the router is going to bring in one port and put out another port is the forward chain. That's the bulk of your traffic. The output chain is anything that the router is sending out to the world. Usually the output chain gets ignored. I can only think of a few very tight security places where you want to make sure your router doesn't go notice to anybody, so you drop everything on the output chain. But then that also means your router loses a ton of functionality.
The nice thing you can do though, if you just wanted to see it, you just don't put any rules in.
You can
You
log
tell it to accept it. You don't even have to log it. You can just see right over here
how much.
how much is coming out. So if that ever changes, you get a kind of a clue. Maybe something's up.
Right. So, are we good with the idea of the 3 chains, input, forward, and output?
Actually, let's just do that for all 3 right now.
Good call.
Let's just see what they'll.
So right now, we're going to just put an accept rule on every chain so we can get these packet counters. And these, one's by packet and one's by size of data. So we're watching both what's going on. And we can reset these at any time with that. That's really handy when you're troubleshooting, because especially if you're troubleshooting firewall problems and you think that maybe there's firewall rules that are stopping something, then you can reset everything to 0 and then try what you're doing and see which rules the packet count goes up on. And then you kind of got an idea of which rules are doing something with this data. So,
And because input is kind of low here, if we wanted to find out what all the input stuff was, a nice way to check is just tell it to log it. And I'm not going to turn it on yet, so we can just kind of see how still the log is. The log isn't going to say much right now,
see, it's not really moving,
but we're going to turn this on.
but you turn that on and now all this stuff's getting logged. Which is also valuable in troubleshooting because this is giving us a lot more information than just packet counts and data count.
If we freeze it in the top left, it'll stop where we're at. We can see what it's coming, which interface it comes in on, and because it's an input rule, it doesn't go out ever. It just comes straight in. We can see the type of protocol it's using, TCP, rather than
This is even telling us that it's an ACK packet.
acknowledgement. Which IP it is coming from, what IP is destined to go to,
And ports.
and the port numbers it's using in between. You can tell that it's doing something tricky with NAT here, and even the length of the packet itself, which isn't really useful, but sometimes you may want to limit that, I suppose.
So this right here is like one step above actually doing packet captures. This is like a quick way.
You gotta do packet captures too.
Yep. This is a quick way to just get an idea of some traffic that's flowing right now and an overview of what it is. If you have to go into so much detail that you actually want to look at all the contents of the packet, are you familiar with a tool called Wireshark? No? Okay. So Wireshark is a tool that you can, it's a networking tool that you can use, it's cross-platform, that actually captures all of the network packets. So you can analyze, you can put the packets back in order and you can analyze all the traffic data and what's inside of it and everything about it. These let you create dumps for Wireshark or for other tools like Wireshark. Go to tools.
I was going to turn on forward logging, just so
Okay.
you can see this view. It's good to isolate some of your stuff to keep your logs down, because otherwise you end up with something that looks pretty disgusting, I suppose would be a word for it.
Yeah.
If anyone starts a video up or anything right now, it's going to get hammered. And then your logs get filled up. Oh shoot, I didn't mean to close that. But anyways, where do you want to go?
Let's go show them. Go to tools. Go to packet sniffer. So here is where you can create a dump file that you can upload into a tool like Wireshark.
It gets stored into a files folder here.
Yep.
And then you can just connect to this, or you can drag and drop things if you're in Windows.
So yeah, any file that gets created, a backup, this type of file, if it downloads new updates and things, they all get put in this one files list. And if you're on Windows, it's a Windows program, Winbox is. If you're on Windows, you can just click and drag things in or out of that files list, and it'll save it to wherever you drag it to. The packet sniffer, you can put in your interface and whatever limits you want for what you want to sniff. If you're a software developer and you have developed this server software that does something fancy, and you're debugging it, you're running into some problems, and maybe the problem that you're at, you know it's not really in the software, it's something with the network communication, then Wireshark would let you see every bit of data that goes on the wire so that you can go through it and figure out what your program's doing.
Do you want to look at it?
Yeah, do I have Wireshark installed?
I was going to look at the file.
Oh, okay.
We're going to do this hardcore.
All right, let's do it. Let's do it. The beauty of Wireshark is you saw how much data that can be so quickly. With Wireshark, it has built-in tools that allow you to automatically rebuild those streams. If you capture all the data from a VoIP conversation in a packet or in a packet dump, you can load that in Wireshark and you can extract the actual conversation. That's how powerful Wireshark is. It can let you rebuild all of the data at whatever level you need to.
Oh, you're on this. Sorry.
Yeah, I can talk to it, but
1.240. You're not on.
I'm on the lab network, not on that. There's no route back. You can switch me.
No, we're good.
Okay.
Uh-oh. We were good.
What'd you
Just
do?
crashed Nautilus for no reason. I don't know, man.
It's still there in the bookmark.
Is it?
Try it again.
Let's see if we crash it again. Master Knowles.
Wow. Crash every time. Cool.
Do you have an email?
Anybody here wants to be a Linux developer, this is where you should start.
Yeah.
What's it crashing?
It
Nautilus.
crashes Nautilus
Nautilus
when he
crashed.
clicks on a bookmark.
Yeah, it's weird. We'll try FTP instead. We'll turn FTP on real quick. Wasn't the question asked last time? Why would you want to turn an FTP server on?
Here it is. It's a debug.
That's already on.
This is an important place, by the way. Whenever you set up a new router, these are all the things that are on by default. These are services that are running on the Mikrotik. This isn't a complete list because we turned on DNS and some other things. But these are the main services that allow you to talk to it.
What's your admin password?
On my computer,
On this Mikrotik.
nothing. That might be why SSH is crashing. You probably have to set a password actually. So these services usually I come through and I turn all of them off except for SSH and Winbox, unless I have a reason to use the others. Telnet, I can't believe that's on, honestly. That should never be on by default,
Yeah, you should
ever.
check on it.
Telnet is not secure and never will be. It's been abandoned for decades. Telnet should not be used, period.
Used for legacy on a default configuration.
That's, well,
Hail Mary.
yeah, that's, I don't know.
Alright, we may have.
I usually disable it first thing.
Yeah,
we may have locked up
for
your
sure.
computer a little bit. I'm gonna move this over here so I can
Okay.
do this.
All right. The API. This is an interesting one. This is something Nathan and Jaron use a lot. The API is a built-in programming interface that Mikrotik has. So if you're a developer and you're writing maybe a web software that's going to help config these routers, or let's say you're building your own hotspot system or something, or they're an ISP and they have their own web interface to manage all the different networks and stuff. You can write within your program, if you learn their API, you can talk directly to the Mikrotiks through the API and make program calls to change things. And you can set up a certificate and do SSL as well for encryption. FTP just lets you send files to the file list. I usually turn it off too. If you turn FTP off and you use SSH, you can still SCP files back and forth. SSH is SSH. We all know what that is. That's secure shell. Lets you log in. There's a nice command line interface to this through SSH. Nicer than most routers. Winbox is what we're using, and then the web interface is on right now. This is the packet dump.
Yeah, that's gross.
Wireshark knows what that is.
Yeah, Wireshark can decode it.
The web interface, www, if we went to the IP of the router right now, it should pop up with a web interface that allows you, show them the web interface. It looks a lot like Winbox. It's not much different at all. Just drag your tab over or whatever you want. Or drag the whole thing, doesn't matter. So here's web config.
Because there was no password, it didn't ask for one. But if we would have actually set up a password like we're supposed to,
Right, it would have asked for a
it would have
password.
asked for something to log in.
So you can see our menu system on the left. It's a lot like Winbox. Everything's there in the same order. There's firewall, this is where we were. I don't like web having access to the outside world on routers, so I usually turn this off. But for people that have a home router and they're maybe just clever enough that they're going to get in and change some things here and there, but they're not using this every day, so they're not going to SSH into it or they're not going to use Winbox, this might be perfect. Just make sure you firewall the web traffic from the outside. So, that being said, let's go back to firewalls.
Let's get out of here.
Yeah, let's get out of here. So now our firewall. Let's go to our input chain and let's firewall web and let's firewall DNS. Because the web interface is on the input chain, right? If we talk to the router and we're asking for its web interface, it's coming from the router. Our data is going to the router directly. So it's going to be on the input chain. So the input chain coming in Ether1. This is important. If we want the web interface to be accessible from our private network, but not from the outside world, then we want to say any traffic coming into our public interface, which is Ether1, on the input chain that's looking for port 80, which is web. Destination port 80, TCP 80. We want to drop. All right. We'll talk about tar pit if you want. So drop is what you think.
Technically, reject is the best thing for this,
Yeah.
but we can drop.
Not if you don't want them to know what you're doing.
That's true.
Right.
Yeah.
So let's talk about the differences between drop, reject, and tar pit. Drop, it's just going to drop it. Forget about it. I like to use drop because you don't want to use any more resources on your end than you ever have to. So if it's not what you want, just forget about it. Just drop it. Reject is going to actually send them a reject saying, nope, I blocked this. If they're a spammer, you just identified yourself and that you are a firewall, that you're firewalling, and I'm firewalling this. You know, that's not necessarily what you want an attacker to know. Usually you just want to drop it. That way they don't know anything more than what has to be obvious.
Chase's laptop is like an outside computer because it's on the the network over here and not the wireless network like you guys are on.
Because I'm on the lab network, so I'm coming from the public.
So right now this is working. It's working just fine because we have to be careful with the order of our IP rules. Rules in the firewall are always handled sequentially.
In order.
Yep. So it starts with rule 0 here, and with rule 0, our input chain was accepted. So anything that comes in, no matter what port it's on, it's going to take it, and it's going to say, okay. So it never actually reaches our next rule here, or our next input chain.
So it never reaches the drop rule. It gets accepted before it gets dropped.
Yep. So you just need to
So if we disable or if we move it up,
bump it up above the other one.
so now the drop rule's first. Now if he hits refresh, it should break.
Yep. It's going to hang, and you'll see it right here. You'll see it gets your packets.
Yep.
And you can see it's just spinning over here.
Like nothing's there. So, tar pit was the third one of those. Tar pit is where if I tar pitted the connection instead of dropped it, then my router would reply to the person saying, oh yeah, I'm going to send you the data. And then when the person asks back finally like, hey, please send me the data, our router will say, oh yeah, I'm going to send you the data. And it'll never send it.
Just hang on.
So,
And it keeps the connections open.
that's right. The beauty is that it keeps the connections open. So you can do this for like maybe a couple scenarios. If somebody's attacking you and you're trying to track them down, you can keep their connections open as long as possible.
And potentially burn up their computer.
And that's the other part. If they're spamming you or if it's a denial of service and you tar pit, then you're holding all those connections open on their computer. So that's massive amount of resources that they have to spend to talk to you, and all your router has to do is say like, huh, okay, yeah. You know, your router is not doing much, but their router is working really hard to try to talk to your router, or their server, or whatever it is. Their botnet, their...
But presumably it sounds like what you're doing is a sin attack yourself.
For which part?
What you're talking about is...
The tar pit?
Yeah, it sounds like a sin attack, except
It's
you're
under-
not initiating the connection.
Yeah.
Right.
Exactly.
Yep. Essentially, yeah. Yep.
So you
It's
can
a sin defense.
within your rules, when you start logging things, you can put a prefix in right here, which I just label this one as drop webfig, because that is what we're doing.
This is a Linux user group, but you're free to use the lab.
Yeah,
However,
we're not-
just don't let us bother you.
We're not holding you up.
Or you can join the conversation, whatever.
But anyways, you can add prefixes on your rules if you log them. And because I labeled this as drop webfig, it's going to show up here as drop webfig in your actual logs. You can see that it's coming from Chase's laptop here. It's 241, going to the router 240 on port 80.
So now let's firewall DNS, but let's let them make this rule. So the important information for DNS, it's TCP and UDP 53, right?
It's mostly UDP, but there's some.
So port 53,
UDP is where all the attacks come
both
from.
UDP and TCP. This is what we need to block coming in, because remember we set this up as a DNS server so that it can proxy DNS from the inside. So if this were plugged into the real outside world, then we would be exposing ourselves to denial of service through the DNS server. What you would have is botnets attacking you, asking for DNS queries constantly, as fast as they can. And they're going to try to get your router to go into a loop where it's always answering and uses all of its CPU and memory, or whichever comes first. So what we want to do is make sure that anything from the outside world can't talk to our router through DNS. We only want our private network to be able to talk DNS through our router. So on the input chain, we're going to make a rule.
Oops, that was my bad.
We're going to make a rule, and we're going to say anything coming in our gateway port, which is Ether 1. So anything coming into our public port on TCP 53 as the destination. Because it's not our router talking out on 53. It's something talking to our router on port 53.
Someone hit some web pages real quick. Oh, shoot. On the wireless, just browse a few things. Hang on, I gotta do
Not on
one.
it anymore.
Yeah, I gotta do one thing real quick. We're gonna flush the cache, make sure that we're not. There we go. All right, yeah, go for it, guys. That should get something. There we go.
All right.
Oh, good
No.
old VAR.
Who's IP6?
Oh no. Let me turn IP6 off.
Who's doing IP6?
It's
Pardon
not.
me.
Is it you?
It's not working though. I mean, it wouldn't work. Here we go.
Okay, there's some DNS for you. All right.
So we can see who our primary DNS server we're talking to is over here. You can see that it is a source port of 53, but the destination port is not 53. So you got to be aware of that when you're trying to block this stuff. If you get your source or destination wrong, it may not capture the rule properly.
So what this is our router asking the labs router for DNS entries. And this is the labs router is the DNS server here on port 53. And it's responding back to us. And we're the one asking, so we're coming from a random port, a random high port. So what we're trying to block is incoming DNS to our DNS server. So we're blocking coming in on port 53, wherever the firewall is. All right, destination port 53, TCP. So
Wouldn't it be UDP?
it'd be both.
Well, and if you look over here, you can see the protocol is definitely hitting on UDP, but it does use both.
So hit apply and then copy.
Do you want to accept it for now?
Go ahead and drop.
Okay.
It should be okay. Oh, it's not okay.
Yeah, we're going to show it, I guess.
Yeah.
I don't know where you're going with this, but we're going to show this.
No, it's cool.
So we'll add a UDP rule. That you notice I just hit copy over here. It makes it really easy if you're doing similar rules to just copy one. It creates a brand new rule with everything this one had, and you can just tweak it and modify it back to however you're dealing with it.
So since our rule is the same, we just changed TCP to UDP. That made copying really easy.
Okay.
All right, so now let's.
But on our input, we still have this rule that it's accepting everything.
So it's right. So let's move our drop rules above it. Now let's clear the cache, and then open up Torch and see that DNS is broken.
We don't even need Torch to watch it fill in these rules here.
That's true.
All right. Try to Gandhi.net. Try and
Probably an ad.
yeah.
All right. So now anybody that wants to verify, DNS will be broken. So if we blocked incoming DNS to our router, then why is DNS broken? At what point did we break it?
It's actually still reading things.
Really?
Yeah,
Wow.
because it's receiving DNS from, like you said,
Oh,
the
because
source.
destination.
Yeah.
So, all right, it still is receiving DNS. So DNS isn't broken. DNS should work fine.
Because it was a source port. That was from the torch we did. The torch, we saw, we knew this because of this. The source port is 53, not the destination port,
Right.
as per our rule.
Is it because it's on you're doing one?
If it's,
This is because
Right.
the router's looking it up. If it was someone else trying to attack the router, it would catch it on a
But
destination
assuming
port.
if you put it on these two, then no one could talk to.
Yeah, well, for instance, let's,
put it on the forward.
yeah, let's
Yeah.
we'll put this on the forward and we'll just kind of just show how things get blocked.
So copy.
You want to just copy it?
Yeah, leave the input rules there. Let's build on to what we've done.
No. Oh.
Hit cancel on that one, and then start over. There you go. All right. Did you make?
Oh,
Go ahead.
I got two the same. That's fine. It's
Yeah.
easy.
Okay. Now, before we get too far on this, there's this filter over here. Come click on this.
All right.
This will filter between chains. So if we set this to forward, if we're only worrying about the forward chain, instead of showing all rules, we can set this to forward, and now it's only showing us rules from the forward chain. Now, we talked about them being in order, but you see it goes 3, 4, 6. That's because it's not including the input rules. So this helps when you're trying to follow a flow of what's going on. And that's how you have to think in terms of the firewall. These are flows. And you're following the flow through the rule list. So now we dropped DNS on the forward chain. So all DNS should be.
No.
Yeah. Without that,
You
it'll
wanna-
break DNS.
Do you want to break the DNS?
What's the point of putting this on the forward chain?
Yeah.
I mean, I don't know.
Technically-
What on the 4G?
This whole rule.
There
What
isn't.
were we doing?
There
Well, I
isn't.
thought that you
To
want to
block
put it on
the
the
clock.
internal Ethernet port with something. You want to break it for these guys.
If you wanted to break it.
Keep them-
If we want to break it, then we can just.
Keeping them from talking
No,
to.
You'd want to block 53 if you don't want them to do direct
Right.
DNS resolution.
Yeah.
So that's our goal.
That'll do it right there.
That blocks everything.
Yep.
There you go.
Any port means if it's source or destination. So
Either way.
either direction is going to get shut down.
See you later.
Yeah.
So that'll break DNS for everybody.
Supposed to. Doesn't look like it's catching anything though.
Does anybody do anything? Here. Yeah. It's not catching.
Nope.
Oh, that's because it's on.
That's because it's not.
It's not on the
forward.
4 chain.
It's
on
an
the
input.
Right.
Yeah.
Because I'm talking directly
Because
to the router.
all the devices are talking directly to the router. The router's talking directly to the other router.
So by putting DNS, blocking DNS on the forward chain, we're allowing anybody to try to bypass our router for DNS.
let's just get rid of these.
Is what we're blocking.
This rule is not what we wanted.
No, it's not.
DNS is all input.
It is. All right. So what are some other things on the input chain that we might worry about? Let's talk about ping. This is a good way to introduce the jump rule. So we talked about drop and accept and all that. There's another type called jump, which is going to jump to a new chain, which can be useful for certain things. We're going to set up ping right now. Oh, it might be blocked. No, okay. It's because we're
We haven't
in my
blocked it
router.
yet.
No, I know, but the lab network blocked.
It'd be
But we're
on
not going through the
switch.
lab firewall because of my router right now. Let's go back to the input chain. Close those firewall rules. Get rid of it.
Oh my goodness, they're fine. I'm not going anywhere.
All right.
That was my new one anyways.
Let's filter by the input chain so we can see what's going on in the input chain. And then for our new rule, let's set it to the input chain. And we want to say everything coming in from the public.
Ooh, we can drop peer-to-peer stuff.
That's cool too, but. So everything coming into our public interface. And we want to list it as protocol ICMP. ICMP is the protocol that ping works on. Because you notice ping, it is IP to IP, but it has its own underlying like protocol that it sends the ping packet. It's not TCP. And it's not UDP, it's its own beast. So what we've done is we go back to general. So everything ICMP coming in from the public, and then our action is going to be to jump target ICMP.
This is built in by you. This is not something that you
this is
make.
where you make up whatever chain you want it to go to.
Yeah. By default, it will show the 3 that are already existing, but we're making a new one, so this is all user input here.
So go ahead and hit apply. And then drag that, there you go. So now when we go to the filter, we should have an ICMP chain show up now under our, yep. So we can see the ping coming in. Go back to the firewall.
That's this guy. These will be synonymous.
Yep. So every time my laptop is pinging, it's showing up because he told it to log it with our jump rule. And it's also jumping it to an ICMP chain, but nothing's there.
It doesn't do anything to it right
So when it runs out, it gets accepted because we didn't tell it to drop everything else. When it jumps to a chain and it gets to the end of the list of that chain, it jumps back to the main list where it left off. Does that make sense? So under here, do ICMP.
Oh.
And then so this is our ICMP chain, which is empty. So let's tell it under general.
Oops, I'm in the wrong place. It's already there.
Go to advanced. And we have these ICMP options. You can do a lot of cool things with ping in Mikrotiks. Yeah, I would say leave that wherever. Leave TCP flags. Where is all the cool stuff?
It's under advanced. No, it's here. It's not there.
Go to advanced. Go back to extra.
Extra.
Go to extra.
Extra. I don't think it's here.
I don't know. Jaren, where's the ICMP stuff?
What are we looking for?
Where you can actually like tell it what type of ICMP
What level?
packet.
You want to, yeah, it's right there. ICMP right there.
Is there more that I can't see? Is that my problem? Because the resolution sucks.
Yeah.
Quite possibly.
No, this is the bottom. I can see the bottom.
I can see
What's
the
under
bottom.
your IP4 options there? When you hit the drop down. Yeah, they're there.
This is different than it used to be.
They're all there. That's all the different ICMP options right there.
Interesting.
By name rather than number.
Yeah, I guess maybe before was it by number?
Yeah, you had to put the number in.
Oh, see, I know it by number. I'm confused. All right. So these are different. When ICMP talks back, there's some built-in like codes that it can say exactly what the problem, or maybe not even a problem, is. It can say like, you know, no router, no record route.
You
What
know
else?
what the numbers correspond to?
Not really.
Oh.
That's why it confuses me. I knew it by numbers. I don't know.
Well, that's what I mean. I can look up the types of codes for you.
Okay, let's look at it.
So. One more name different. Source quench is 4, which would be your. You lost. I need your names.
Oh, sorry. I was looking at the code numbers on here.
Yeah, the codes are in the packets there. Did you see that? By number.
They're all type 8 code 0.
Yeah.
Dude, there used to be a lot more options here.
8 is echo, which is your standard. That's
Yes.
pretty much what a ping is.
But where's Echo?
Yeah, Echo's not here.
There used to be more stuff. Been changed.
Oh, this is
Look under extra.
What's PSD? Packet detection? Yeah.
Oh. Okay.
Set the protocol to ICMP and see if that changed well. Set it to ICMP. And then go to advanced.
No, that doesn't change it. It won't change anything in advance. It just doesn't work that way.
I mean, if you do it from the command line, you can still do it by number.
Interesting. So they changed something in the GUI. Let's forget about ICMP. That's very interesting.
Might honestly be a Winbox bug. This is the beta and
Yeah.
it's not indexing something properly.
Anyway, the control that you have
There's
for
connection type and connection state.
No,
the
it's not.
type of control that you have for ICMP would be that you can actually say if somebody pings me, I can dictate what types of replies I give, and I can block certain ones and I can allow certain ones, or I can just count them. Like fragmentation is a useful one. You can set up a log to log whenever there's an ICMP packet that fragments, and then you can have that log report back to wherever your people that watch logs are, because we all know that those exist. Let's talk about connection type. So let's add a new rule.
Where do you want to go for this?
Go to general. Down here, there's these 3 fields.
Oh, right.
Connection type, connection state, and connection NAT
Oh, we don't
state.
need type. Type's not important.
Type is not important.
Yeah.
Connection,
You can develop your own.
connection state, This is really powerful in Linux firewalls. It was so powerful in Linux firewalls that it redefined what a firewall is and made everybody else that wasn't Linux firewalls rewrite their software, essentially. Because this comes down to one of the most fundamental parts of connection tracking. What we can do here is for every connection that exists, we can mark it by if it's a new connection, which means that this is the first time somebody sent this data packet out. This is the first time somebody's trying to establish this connection. So these are all new connections. This is valuable because maybe from our private LAN we want to allow new connections and then just block it everywhere else if we want it. Related and established. Let's talk about established first. Established means that this connection has already been made. So let's say, what's something that we would block that we want to allow but sometimes block?
Yeah.
An inside connection out, it's
Yeah.
established from the inside, but not established from the outside.
Right. I'm trying to think of specific, like
SSH.
So, okay, SSH. Let's say that we want to allow people on our private network to SSH out to the world, but we don't want to allow SSH back in. Maybe we are even running SSH servers within our network, but we don't want the world to SSH in. So we can say established. So we can define that on our forward network going out our public interface, SSH is accepted. Or let's say, okay, on input, let's make a block rule SSH and put it to the top.
Well, you see,
What? Just do it.
you're making a whitelist kind of thing going on here.
Block SSH and put it on the top.
Going out or in? Because no
In.
one's gonna SSH in.
Block SSH going in. Put it on the top.
You could do it with web traffic just as well, actually.
Oh, we already proved, yeah, web traffic already did this too.
Okay.
What are you trying to get at?
Put it to the top of the list. Hit OK. Oh, there you go. Drop.
Calm down, man.
Put it to the top of the list. Too slow and you have too many windows open. All right. So now SSH is blocked coming into our router from the outside world. Totally blocked. No SSH coming in. So let's add a new rule.
Are you gonna block a port for every single type of traffic?
No, I'm just trying to explain to them what established is in a way that they can see with their own eyes. I guess that was a bad example anyway. If you would have said like any port instead of destination port on the drop rule, if you would have said any port.
You block any? Would you want that?
All right.
Good.
So
If it's coming on if it's coming in on anything but 22, your server's not gonna see it.
right, but how is a new one going to be established here ever? It'll never get to the established state.
Basically, if it's established, it's in the connection table.
Right.
So anything that's in the connection table will be allowed by that rule.
I know, you're making a weird
Usually
firewall
used
here.
for
I never make a firewall like
reducing
this.
CPU overhead.
I'm just trying to prove an example, but I'm not driving, so it's not getting done right.
I'll drive.
That's what I'm saying. All right.
Goodness.
What I'm trying to show,
You're making a non-realistic firewall though. That's why it's hard.
I'm not trying to make a realistic firewall.
That's why it's hard.
If I block port 22 either direction on the input chain, that means all SSH is blocked. Everything SSH is going to be dropped right here. If I allow this is in and out, by the way, because it's any port. So if I allow on the input chain anything from port 22, connection state, new, actually I want established, and I want to accept. So what I'm doing here if I leave the drop rule first, then all SSH gets dropped, period. This other rule that says accept established connections means that if my router has already talked out and made the connection, then anything that replies to that is already established, so it's going to get accepted. So if I drag it in front of the drop rule, then I should be able to SSH to something. Isn't there tools? It doesn't like SSH. Is it under? It's not under tools.
Sorry, what?
System. There it is. Yeah.
What's each one?
I'm not sure. Let him drive.
Oh, it's under tools, tell them that. But for some reason. Under Mikrotik, that's the same.
This will Wichita.
Yeah. Oh. This is a Winbox bug, by the way.
Mm.
It's from font scaling.
It's font scaling, yeah. You can fix it by fixing the font.
Oh, really?
Yes. It's annoying. But you just have to install very font in the song.
There's a space, that might be it.
There's a space?
Yeah, before the Wichita.
SSH-L.
There you go. I think that's for the SSH server though. It's your question mark after SSH.
Yeah.
Do what?
A question mark.
You're not using the
after
CLI,
L.
right?
No?
You gotta use it like a CLI, yeah. Use the CLI. You gotta use address.
Address equals.
Yeah. You gotta define everything in the CLI.
No, it's still dropping.
Yeah.
It's not under tools.
It's not called SSH. I think it's called Telnet.
Yeah. It is.
Oh.
And you give it the option for SSH. It's
Um,
stupid.
Isn't SSH just telnet security?
Yeah.
It's not your rule.
It is my rule.
No, it's not.
Yeah, it
Look at
is.
me- Look at me bytes back up.
Well, there's only one packet to go out.
It is my rule. Watch. You can see it dropping. It shouldn't be dropping. It's because
You're driving. Log it so you can see it. That's the purpose of all this. Go to action on this rule.
chain TCP.
Oh, I think I must have this
What's going on?
You have a connection type actually listed there that's got that. You clicked on connection type on accident.
No. Oh, yep, that was it. All right. So, you notice the SSH was blocked until we added this rule that said to allow port 22 that's already established or related. Since we were blocking it on the input chain, when I initiated the connection for SSH from the router, that was on the output chain. And there was nothing blocking it on the output chain. So that connection was already established. So now that the connection was established by my router, the return, even though it was SSH being blocked, was allowed because I allowed established before I blocked SSH. And it was already established connection. Related means that if a connection spawns another connection, that's what related is. FTP does that a lot. Some other things do that. So a lot of times in a firewall, you can make a really, really simple one just by doing that on the forward chain. Invalid means that the packet is not a valid connection, but it kind of seems like one.
Invalid headers.
So usually that happens from NAT or from bad programming, essentially.
Or bad MTUs.
Yeah. Fragments that don't get put back right. So a lot of times you want to drop invalid right off the bat. We're going to get rid of these SSH rules real quick. And we're going to move to the forward chain. Is this just a logging rule?
No, it's just showing traffic.
Okay. So on the forward chain, we can accept new, related and established.
You're going to want to specify an interface somewhere here.
If we did this, and then we put a rule after it that said drop everything, then that's like the empty shell of what would be one of like an extremely secure firewall. But this is a firewall that's based on blocking everything and then only allowing things one at a time, which isn't normally what you'd want at your home or even at a business. But if you were doing something that was based on security, that would be your only option.
You need to specify an interface though, otherwise it'll block. Because otherwise, forward catches things coming from the wireless interface and using that forward, so it'll catch things going over your bridge.
That's the idea. Block everything and then only allow specific things that you've identified. That would be the paranoid secured firewall.
I guess, yeah. To each IP.
Right. That's the idea.
Yeah.
So if the point of your firewall was to only allow the very specific things that you've identified. Is it time? It is time.
Generally,
Then you would do it by this rule, a drop rule, and then filling in what you allow.
Yeah. In general practice, the way I like to set up firewalls, not being overly paranoid, is initially just block all traffic coming into your router, and then allow whitelist instead of blacklist, because you can blacklist things forever. There's so much stuff to just pick apart. Block port 80, block port 22, block telnet, block this. Rather, it's easier to just say, block everything, and then say, I want to allow just Winbox in, and I want to allow just SSH because we're on an SSH server or something. And
Just in this place.
yeah, and just from this place, you can say, block all SSH except just this one IP I want to allow through, or just a group of IPs. That makes it a lot easier to run your firewall where you don't keep having to add things as you start encountering stuff. You can rather add things as you want them to come through. And then on your forward, only allow new things coming out, but only establish things coming back in. So that way there's not people from the outside world making new connections into your NAT stuff. And that's pretty much all you need to do for a basic firewall. And that's all your like home routers come with. If you go out and buy a D-Link or a Linksys router, that's their basic firewall too. They don't have a whole lot of special stuff in there.
Lock everything and see who screams.
Yeah, pretty much. That's the easy way to go with it.
It's usually the safe approach.
That
Easier
was-
to fix the screeners than to
Yeah.
allow all the hackers in the world.
Well, because then if you miss one thing, everybody screams otherwise because everything's crawling
Or broken.
or broken. And you can get more granular as you discover things that maybe need to be opened up. Because sometimes you'll encounter a situation where you'll whitelist something, and then all of a sudden it becomes a lot more picky about, well, I need it for this, and I need this IP that rotates on a regular basis, and this never staying the same, but I don't want it to be, China attacked. So it gets a little more fine-tuned as you start seeing certain situations come up. But
So a lot of your firewall is going to be on your input chain because you're protecting your router. And then like he said, on your forward chain, you just kind of allow everything from the inside going out that's already been established and new. And then that's kind of it.
coming in, just allow established stuff. You shouldn't need to allow new stuff coming in.
But that is a very liberal firewall. But that's usually what you want in a house. Or even a business.
I'll
a
say
lot of
it's a
times.
great place to start at. You can always get more granular. Because the first rule you're going to have is drop all input chains. It's insanely secure from the outside standpoint. Inside, you can kind of pick it apart as you need to. If you're worried about internal viruses spreading, you can start blocking your forward chains internally, setting up certain ports that you know viruses travel along that you're not going to use, and you can shut those down on your internal network even, so that can't travel between interfaces and stuff.
Like let's say you came in one day and there was a virus that spread amongst all the computers in your company or whatever. And everything's just hammered. It's such a mess that you can't even get an antivirus to run to try to clean it up. Then what you could do is you could go to Torch, where we were under tools, and you can torch the traffic, and you can kind of figure out there's a massive amount of traffic that's going on this port. So that's probably the virus that's spewing information out, trying to find new hosts or send data back somewhere. Then you can just block that port on your network everywhere. And that alone will probably even slow the mess down enough that you can get a handle on it to start cleaning it up. 8 o'clock.
We never did get into mangling and stuff, but that's
No
There's a lot
QoS.
of firewalls.
There's a lot to firewalls. You can do cool things like one I've used before.
yeah, it's fun. I'll go home.
See you, Chase.
See you later. Thank you for coming. Under PSD, I probably have to fill in a. Well, let's see. Sorry, I'm thinking.
No,
Oh, all right. So I had to tell it TCP or UDP, but PSD stands for port scan detection. So I can set these perimeters to say that if something is hammering my router, scanning ports at least this rate, if they scan this many in this time period, then I can flag it and do something with it. I can drop it, I can put it on a list and watch it, I can do all kinds of stuff. This is useful if you're looking for attackers. It's useful if you're going to try to block people from scanning you. It's also useful, I noticed, on the Cox network, they actively port scan all of their customers. I'm not really sure why, They claim they're looking for DNS servers, but they scan on everything, not just DNS.
Yeah, mail servers too, I'm sure. And
But they scan everything. They're not just scanning important things.
Yeah.
Cox scans everything. And I had one customer that it became a problem because what were we trying to do? We just had we had something running on an odd port, and Cox kept calling him, telling him that he had a virus, and then he had to fix it, otherwise they were going to shut him off. So I'm like, why do they even care? First of all, it's not spewing a bunch of stuff out. It's just some random server that they know nothing about running on this guy's router. And I was trying to figure out how they even noticed that. And so I watched the logs and I watched Cox port scanning him. So I changed the port that the service was on, and I set this PSD detection to drop anybody that tried to scan him. And sure enough, he never got a call after that. It actively stopped Cox from scanning him to see what he was running, which was nice. If this is the border router of a decent sized business or company, you probably want port scan detection. If you're big enough that you think somebody might try to target you and hack you, you probably want port scan detection as part of your firewall. You can set limit rates. I've seen people use this if they watch this for SMTP, which is mail, and you say all outgoing things on the mail protocol. If they start so many connections per second, then flag that IP or drop it. So you're looking for mail spammers at that point. This is an effective way to do that. You can do it by, I think this is by, this is connections per second, and this is overall connections for a network. So you can do it by a couple different ways, or by destination.
Well, yeah, connection limit is the number of connections, and the limit is the speed at which they acquire new connections.
Right, connections over time.
Yeah.
Nth, I don't know what that is. Oh, it drop every 2 packets, I guess?
Yeah,
I don't know.
exactly.
Every so many packets do something. So that would be if you're polling.
Or slowing it.
Do what?
You can do anything. This just recognizes that it's there. It's up to you what you want to do in the action. This is not actions. This is just sensing things. So this is saying if you notice 5 connections in a 10-second period of time, drop it. You can send that IP to a destination list so you can see what it is later. This list doesn't say what to do with it yet. Now this list does. The
So what
action
you're
is
talking,
you can do about it.
what you were talking about, where you want to like slow somebody's connection under certain perimeters, that would be more of the QoS and mingle type stuff.
Yeah, we can talk about that.
That's not really firewall. Firewall is pretty definitive actions, not the soft actions like limiting, which can be done, but that's not really a firewall thing. It works a lot like the firewall. It's part of the firewall, just not this part. That's under Mangle.
There's the Mangle tab there. That's where you find where packets are going to be coming from and where they're going, and depending on what interfaces they're going through, you put a little mark on them by a name. It's a label, and then every time that packet goes through the router, it carries that label with it, and you tell the router if it's got this label, no matter where you go through, maybe restrict it a little bit or give it more priority or less priority over this other packet that has a different label. So as you label things in the router as they flow through, you can give them priorities or traffic limitations, things like that. That's QoSing, or traffic queuing. The Mikrotik actually has a very good queuing system. They have a couple different types of queues. And you can even tell a whole interface. You can say, I just want this interface to be limited at 500K in a second. And then we'll just walk into that. So no one else will do anything.
Okay. Calling it a night. Did you learn something about firewalls?
There's a lot to networking.
Which model is the home model? Model for the home?
The HAP is what they call it. Mikrotik HAP. The 951. This is the model of this one that we're playing with that you guys saw here. Is a 951G-2HND.
You're looking for one for your house?
Yeah.
If
I
you want,
highly recommend, write this down, 2011 2HND. Is that it?
yeah.
That's the model.
Yeah.
2011 2HND.
If you buy this one online, it's $70. I think that one's 130.
That one's 130. But I've never put that router in somebody's home and they weren't absolutely thrilled. That's an amazing router.
It has 5 fast Ethernet and 5 gigabit. If you're only worried about the 5 gigabit ports, this is probably a better one anyways though.
And it's got high power wireless.
So it's kind of up to you on kind of how much you need. The one he's talking about actually has 10 ports on it, 10 Ethernet ports. 5 of them will be fast Ethernet, 100 megabit, and 5
Has a
megabit.
USB port.
This one has USB. It's for a 3G card you can put in it. So you could technically run like a cell phone plan on it, and then if anything fails, it still has some kind of link to a network somewhere. It's mainly made for remote site stuff. The serial port is also used for a serial connection to debug it or get it out of a factory locked situation.
And they do hotspotting?
Yes. So when you buy the routers like this, I think almost all their new ones come with a layer 4 or level 4 license. They have levels to their license, and level 4 allows you to run an AP mode, which will allow you to have hotspot or wireless clients connect to it. But these all come with level 4 license, which allows you to do that. So.
The only licenses that don't allow you to do that are like the free ones and the demo one.
Level 3 won't let you.
But level 3 doesn't come on anything. That's like a specific thing that you
It used to come on the 411s.
Really?
Yeah. And
Is that what the cable company in Wellington supplies their customers?
yeah, we have these. Exactly. That's actually where I got this. This is straight from work right now. Yeah. Like, yeah, you can buy them. Amazon has these. I know. We sell them with a markup, so you're gonna have to get that. But, so we gotta ship them in ourselves. But
This one is a pretty nice router.
we sell those for $100. If you buy them online, they're 70.
They don't, the wireless, it's the same card, but these have a built-in antenna, and it doesn't work quite as well as the antenna on the other one.
I've actually found that different.
See, I've had the opposite
Yeah.
experience.
Those are-
The antennas work great until you get like through walls and stuff, and then it degrades much faster.
Are you sure you're not talking about the 951 non-HND?
No, I'm talking about the 2HND. Exact same card.
Yeah, I've covered whole offices with these really well.
So you talked earlier about,
Oh,
like
also they don't have
extending,
email.
that you could set up 4 or 5 of these things and hop?
You're talking
or
about the
extend
other
them? And you started to
Oh,
talk.
that one does have email. Do what? Like hop.
Well, you get out to the edge of it and then you put another one
You're talking about wireless?
in. Yeah.
Okay, yeah.
But
detecting
really,
that range, or?
the best way to do that is really to run a hard line back to some core. If you're going to the edge of your wireless and you want to put another one, to hop from the edge isn't really good, but to run a line back to your core
Well,
router.
actually, you know, some of the stuff I work with, you get out there, you don't get to the edge of it. You know you're getting close to it. And some of them outfits out there, they sell these things, you just well.
Like range extenders. Yeah, those aren't really.
Extender.
That's not really the right way to do it.
Yeah.
That you run into other problems,
Range
especially when you extend further and
Well,
further.
you run into problems like your IP address.
Yeah.
Change.
It's like you said, it's always best if you are doing multiple hotspots to hardline the hotspots themselves,
Okay.
so that you're not piggybacking your wireless over your existing wireless.
Then it just gets hairy.
Yeah, every time you start piggybacking your wireless, you basically make an overhead layer, and it gets slower and slower.
Oh, well, I like it, I'm lazy, I don't like to run like that.
Yeah.
I don't have to.
They generally call that a WDS network, and every hop you make actually cuts your wireless in half.
Yeah.
So if you get,
Well, you
if
cut
you
it
get
half with wireless anyway,
well,
as a rule.
Well, but then every hop you cut in half again.
I say technically these.
And that's not good.
So if you start with 54 megs, suddenly you're at 24 megs, and then if you're 3 down, you're at 12 megs, and that's in a perfect condition. So otherwise, you may be capping yourself at like 3 megs.
You get 100 feet of Cat5 cable and just start stringing it out.
It's the best way to do it.
Well,
It is true.
I used to change things.